Greetings, Saintsmen. We got a lesson 11.1 regarding circumference and arc length. Our final chapter, chapter 11, is kind of a culmination of all of the things that we've been doing throughout the course. And we're going to do an exploration of area and volume and start to explore a third dimension with regard to how we measure things. I think the important thing is that we're going to take into this the logic of the various other formulas and the various other facts that we've learned in order to, again, formulate and create the equations that are going to help us solve each of these problems. Remember, when we discuss circumference, which is going to be characterized as capital C, it is equal to pi times the diameter of that circle. This is one of those things that I want to go back to, which is that circumference over diameter is really the ratio that we create to create this number pi. That pi is equal to circumference over diameter. Don't be so concerned with the approximation of 3.14159265535 yada yada yada. It's not really that exceptionally important. You need to really have committed to memory that it's over 3.14-ish times. And that'll be sufficient for you. But the idea is that in terms of what it is exactly is it's this ratio, which is always going to be for every circle, that length all the way around it, or effectively what the circle's quote-unquote perimeter will be. It's that length compared to the length across the circle through the center, or in other words, the chord that goes through the center, in other words, the diameter. Let's go ahead and solve some problems here. This should be a relatively short and quick lesson. We're going to find the circumference of a circle with a radius of 11 inches. Again, this should be short for us, right? Because remember, we're going to go back to our initial equation. C is equal to pi d, right? And remembering what diameter is always equal to, because right here, we're not given anything with regard to diameter, but we're given the radius. Remember that when you have a circle, right, that from that center, any length from the center to a point on the circle is going to be called a radius, all right? This is a little bit of review. So if we go through that and create that quote-unquote straight line, that 2 times that radius is going to be the chord that makes the diameter. So this should be pretty straightforward. If we're going to find that circumference, we're going to say we're going to have pi. And then instead of diameter, right, we have 2 times r here, right? And we're going to substitute that with 2 times 11, in this case, for the radius to create our diameter. So our circumference is equal to 22 pi inches. Gentlemen, leave your answer just like that. There's always this temptation that we have to multiply out that number, but the same way that we have been leaving answers like 3 rad 2, right, rather than writing rad 18, and then moreover, rather than putting that into a calculator and giving a decimal approximation, right, an approximation is what it's about equal to, we're not interested in that. This is the exact answer right here, and this is what we're looking for in the world of geometry. Exact answers. Exact measurement. The radius. Find the radius of a circle with a circumference of 4 millimeters. Okay, so now we're given circumference and we need to go back and find radius. So again, we go back to our original formula. Pi, circumference is equal to pi times diameter. Now they give us circumference, right? So we're going to substitute. Instead of c, we're going to have 4, right? We have pi. And then now we need to substitute for diameter in terms of radius, which would be 2 times the radius, right? So we don't want to work with that variable d. We can convert that to r because we know, again, that diameter is equal to 2 times the radius. So we're going to go back through here. In other words, we're going to have 4 is equal to 2 pi r if we were to reorder this bad boy. And then in order to solve for r, first things first, I'm going to divide by 2 on both sides, right? This guy's going to factor out, okay? And this 4 is going to become a 2. I also need to divide by pi on both sides, all right? So that I can get rid of this pi and now have just r. Now look what I have on the left. I have a 2 over the pi, And that is equal to r. Gentlemen, that is your answer. That is in millimeters. Whatever that approximation would be from 2 divided by 3.141, yada, yada, right? So roughly about a little bit over 2/3. Good, great, grand, wonderful. But 2 over pi is the exact, 2 over pi millimeters is the exact answer here. Let's now discuss arc length and how we're going to find that. Let's create a circle. General size. I hope you still have that compass handy that we're continuing to need. Please make sure that you do bring it to class. I may have a compass quiz at some point during this chapter, which is a pass-fail quiz. It's an A or F, right? Either we have our compass that we're supposed to have or not. Okay. So, let's make our circle. Our circle named O, or, yeah, O. And then I have this radius here, this radius here, and then a point on the circle. I have P, I have R, and I have Q. So I have a circle O with those points on the circle, and I have a central angle of 100 degrees. Well, we're going to find, given also that we have a radius of 12 inches, we're going to find the measure of the arc length, not what you guys are used to with finding the measure of the arc in terms of its degrees, but we're going to find its arc length. Now, just know this, it's actually not that crazy because it's going to be proportional in terms of degrees. This right here, this quote-unquote pi piece is what's referred to as a sector. Now, there's two things that I want us to take out here as we go forward. Remember, their circumference is equal to pi times diameter. Moreover, in this case, we're given a radius of 12. So we should know that our diameter, d in this case, is equal to 24 inches. Okay? Please note that the sector, that pi piece, to the whole circle is going to be the proportion we're going to use. In other words, PR is our arc, okay, versus the length around the whole circle, in this case, is 24 pi. Question, of course, is how do we get that? Well, it's through this, right? We know our diameter, which is 24, so our whole length around is 24 pi. So then we're going to say, for arc PR, we know that it's an 100-degree arc for that sector, right? For that central angle. For the whole circle, proportionally going to be 360 degrees. So this is going to be pretty straightforward in order to solve, right? Let's go ahead and solve it. So we have PR, arc PR to 24 pi is equal to, and then I'm going to put over here, it's 100 to, so it's going to say 10 to 36, right? So I'm going to multiply by 24 pi. Some of you guys are like, whoa, what'd you get from 10 to 36? Well, I just reduced as I went along here because I'm going to try to do that as much as I can before I'm going to mess around with throwing stuff into calculators. But we also can just do that in the end. So 24 pi is going to factor out. And I have the arc length PR is equal to 240 pi over 36, which again, I can reduce this thing, right? So let's again divide this thing by another 2. So I have 5 over 18 times 24 pi, okay? And then I can continue to reduce this thing. Let's multiply this guy out. 24 times pi, so 24 times 5. So 24 times 5, right, is 120 pi over 18, and we can continue to reduce, right? I can divide both of these guys by 6, right? So 120 divided by 6 is going to be 20 pi, and 18 divided by 6 would be 3. So 20 pi over 3 is going to be the arc length of PR, and I'm just going to leave it just like that. That is your answer. All right. Speaking of which, my truck needs new tires. So, makes me think of this because of how they do this whole thing with tires and how they measure these things. So like, for example, my truck had an issue that not only did I lift it, I put on a bigger wheel and a bigger tire. So one of the problems I have is that now my speedometer isn't exactly accurate. It's not too far off. I didn't do anything crazy because I just have a little 4-cylinder Tacoma. But think about this logically. I have a cousin who has a gigantic F-250 that he put 37-inch tires on. And we had an issue with me driving it because I was doing what I thought was the speed limit out on the Highway 8 going east. So well past on the outer portion of the county where it turns into a 70-mile-an-hour speed limit. The problem, though, is because of the changed aspect ratio, which is this. By the way, RPM, as you look at that, right? Meaning revolutions per minute. Now, it's not in this case referring to, when you see that in your car, that RPM, that's actually referring to the flywheel connected to like within your engine and how that thing is spinning around. That's not actually referring to the revolutions your tires are making. But back to the other issue, 37-inch tire on an F-250. You have to imagine if it rolls around one time around that circle, right? It makes one revolution. If that circle is bigger, the tire is bigger, it's going to travel more distance. Now, if the engine is working the same amount, right, and is outputting the same power, but is technically going to be traveling further and therefore faster in a short amount of time, right? Think about this: distance is equal to rate times time, right? So if I to get that rate, it's going to be distance over time. If I increase that distance but keep the time the same, that's just going to be a bigger number, meaning that's going to be a bigger rate. But if it's not calibrated correctly on the speedometer, when you're going 70 miles an hour in a lifted truck with bigger tires, the problem is that on the speedometer it says 70, but it really turns out to be like 78 miles an hour. So I was, it turns out I was exceeding the speed limit, but I wasn't really aware of it. My cousin had to tell me to slow down, and I should have kind of figured it out because I was, looking around and as I was driving, passing a lot of other cars rather quickly. And I just thought they were just driving slow. So let's just go ahead and take this 15-inch wheel here. And then it has this aspect ratio. So for example, like if you guys see on my tires, or on any of your tires, right, you'll see these three numbers. So for example, I've got a 265, 70, 17. And so what that means is that this is referring to this overall diameter, okay? But what we have here, the 70, is referring to this aspect ratio, and that's going to change with regard to 17, which is just this inner wheel, right? So the bigger this number gets, the smaller this number is going to get. Excuse me, 60, 65. I take that back. The The bigger the 17 gets, the smaller the 70 is going to get, right? Because this guy is going to decrease in size, right? Versus if I had like a wheel that's going to be smaller, right? I'm going to need it then to have a tire that's going to be quote unquote like thicker. That's that aspect ratio. So enough about tires. I know it's a really fascinating subject, but a lot of you guys are starting to drive, and some of you guys are fascinated with these things with cars. So just throwing out some little facts for you guys. So let's take this just particular situation. So to the nearest foot, how far does this tire travel when it makes 15 revolutions? So we're just talking about not the flywheel within the engine, but we're talking about the revolution of the tire. Okay. So again, that distance around it, right? If it rolls one time around, there you go. That's going to be that distance or circumference. That's going to be the distance it travels with one revolution. So circumference is going to be equal to pi times diameter. And let's figure out what your diameter is. In this case, it's going to be 15, right? All right, from that center. So there's that inner circle is 15, but then there's an extra 5.5 inches on either side. So your overall diameter is going to be 26, as it turns out. So your circumference is 26 pi. We always put pi on the end. Okay. And then the distance, in this case, total distance, is going to be the total revolutions. The entire time you're going to go, one time around, and it's going to do that 15 times. In this case, times 26 pi inches. So it travels 390 pi inches. Okay? Which is not what the question is. It's asking me to the nearest foot. So I'm going to need to go here and divide this number by how much? Well, how many inches are in a foot? So, of course, I'm going to have to divide by 12. So this is going to be 32.5 pi feet, which is your answer for the record. Because, you're going to go into the tire shop and talk to them about, oh, yeah, it's 32.5 feet. And they're going to look at you like you have two heads. In this case, you can multiply this out by the pi approximation. Your calculator, by the way, has a pi button. We've discussed this before. I would utilize that in order to get about roughly 102 feet. Okay. Which answer do I want? But for both. The last part of this lesson is to discuss another unit of measure. Convert to radians. Sorry, convert 30 degrees to radians. So why do we use degrees? Like, doesn't it seem kind of arbitrary that it's like how many ticks around the circle, right? And how many ways, so we can subdivide a circle into 360 parts to effectively create these 360 degrees. And I don't know why we really decided it was that. Nonetheless, because we can relate that length around that circle to the length across it, and then you can even subdivide that in half by the semicircle, right? Which is going to be the 180 degrees that you guys see with the protractor. We're going to utilize this other unit measure the same way that, like, why arbitrarily do we use inches versus centimeters, right? Just a unit of measure. We have a better number sense. For the most part, there's Americans in our classroom that have a better sense about distance when you relate it to something that's in the traditional American system of inches, feet, and miles versus the non-Americans who utilize the metric system and understand better centimeters, meters, and kilometers, for example. We're going to use the following conversion to go from degrees to radians. So I'm going to give you guys how to do this each way. To go from degrees to radians, we're going to multiply the degrees by the following. You can multiply those degrees by pi radians over 180 degrees. Okay? And to go from radians to degrees, you're going to multiply your radians by 180 degrees. So it'll have 180 on top versus pi radians on the bottom. Okay? And when you do this in this unit conversion, as some of you guys have done this in science class, when you do a unit conversion, for example, if I got a 30 degrees right here, and I'm going to multiply it. Now look, I'm going from degrees to radians. So which one of these methods I'm going to use? But the one on the left, right? So I'm going to go and I'm going to multiply. And notice because I have this degree in the bottom, degrees by degrees is going to factor out. Okay, so I'm going to have, again, pi radians over 180 degrees. Okay, and the degrees and the degrees are going to factor out. And then the 30 and the 30 are going to go, right? 30 is going to go away because now I'm going to factor this guy down to become 6. Okay, so effectively I have pi over 6 radians as my units, and that is the measurement of that angle. It's not a length, but it's the measurement of that angle. All right, giving you guys an idea. Again, you have that RAD button that I told you guys to avoid for now. when we did the trig chapter. We're not going to have a usage for that until you guys get into study more trig and then in pre-calc. But for now, we'll leave that radian button alone, but you understand now that it's a whole different ball game, a whole different unit of measure. But we can do that conversion over here. All right, pretty straightforward. If you guys have any questions, of course, you can reach out to me or see me during office hours, and we'll get started on lesson 11.1.